Welcome to Think Energy, a podcast that dives into the fast changing world of energy through conversations with industry leaders, innovators, and people on the front lines of the energy transition. Join me, Trevor Freeman, as I explore the traditional, unconventional, and up and coming facets of the energy industry. If you have any thoughts, feedback, or ideas for topics we should cover, please reach out to us at thinkenergy@hydroottawa.com. Hi, everyone. Welcome back. Okay, so it's time for another explainer episode. Just as a reminder, I plan to do these from time to time to make sure that everyone is up to speed on some important foundational concepts, things that we talk about often on the show that maybe we take for granted that everybody knows what we're talking about, because this is the kind of thing that's we sort of live and breathe every day, and not all of our listeners are there as well. Today, I'd like to quickly go through something we mention a lot on the show, and we probably mention it using the acronym DERs, but distributed energy resources. That's the acronym DER. And I'll probably be referring to them as DERs here on the show from time to time. But so I wanted to give you a bit of a basis of that. It's something that you've probably heard a number of times. It comes up in a lot of different aspects of our conversations here on the show. Um, DERs are not necessarily brand new technology. They're not necessarily new things, but their role in our energy transition is evolving and accelerating, and we're going to see a lot more of them as we move forward. So I think it's important to sort of set that foundation and set the groundwork so that everybody knows what we're talking about here. So, what are distributed energy resources? Well, as the name suggests, they are small scale generation or storage resources that are located at or near the point of consumption, like our homes and our businesses. And before we talk too much about them, I think it's important to understand why they are unlike our traditional energy resources. So, for the last 100 years or so, our energy has been primarily centralized, at least in the case of electricity, especially. One of the great engineering marvels of the last century that I know I've talked about on the show before, and something that we still benefit from today, is the centralized electricity grid. So across Ontario, Canada, North America, there is this vast interconnected grid that brings relatively affordable electricity to customers from large scale centralized generation. The generation technology of the last 100 years has made the most sense when it was built at a large scale and when it was centralized. So, not everybody had a river or a waterfall in their backyard for hydroelectric generating station. Not everybody could build a coal or gas fired generating station in their backyard, nor would we want that, nor would you want to have a coal fired generating station in your backyard. So, as we were scaling up our use of electricity in the last century, it made sense to centralize this generation, to build it big so that it could serve the most number of customers and to transmit that electricity to where people used it. Um, these types of projects, and let's include nuclear in there, I haven't mentioned that yet. These are large, complex, major public projects. So you're not going to build a bunch of small ones. You're going to want to centralize that for economies of scale and things like that. So that centralized approach has worked well over the last century and will continue to be part of our energy mix moving forward. We're not getting away from centralized generation and our electricity grids, but things are changing. There are now other options on the table, and these other options are set to play a major role in our energy futures. Enter distributed energy resources, or DERs. DERs are things like small scale solar or battery storage, in some cases, wind turbines, and even your electric vehicle. These technologies mean that some of our energy needs can be met not just from a distant centralized generation station, but right from our own rooftops or our driveway. Why is this important? Well, DERs have a big role to play in our future, and there are many benefits to DERs. So, first off, let's put ourselves in the shoes of a homeowner investing in some kind of DER, let's say solar on the rooftop. Being able to generate your own electricity gives you some control over your energy needs and costs. Think about investing in a DER as locking in some portion of your energy costs now for the life of that equipment, regardless of what happens to sort of the market rate of electricity and electricity prices over time, you've paid for that solar generation. You know what that costs. It's in today's dollars, and you've got that generation for the life of the equipment. And that kind of locks you into that. It gives you some predictability and it insulates you from sort of what's happening in the market. You also have the opportunity to use your DER in conjunction with the rate structure of your utility to really minimize your costs. So let's say you have a battery and your utility has a time of use rate option like we have here in Ontario. If you charge your battery during an off-peak time when electricity is cheap and use it during a peak time when electricity is expensive, you can really drive your costs down. And all of the electricity you're pulling from the grid or some large portion of it can be at that lower off-peak costs. That brings me to my next point, which is the carbon impact of electricity. So, we talk a lot about climate change on the show. We talk a lot about the fact that really what we need to do is drive down our carbon intensity, to drive down the amount of carbon we're emitting. And how much carbon is emitted from electricity generation really depends on where you live. But let's take Ontario as an example. Most of our electricity in Ontario is emissions free. So we have a large amount of nuclear, we have a lot of hydroelectricity. We have some large scale solar, a lot of wind turbines. But we do still have gas fired generation. This typically shows up during our peak times when electricity demand in the province is at its highest. So if you can rely on your DER during those peak times, your battery or your solar panels, rather than the grid, you are avoiding using more carbon intensive electricity. And if we scale that up to more than just the individual perspective, the more DERs we have that reduce our overall system peaks, the less we have to rely on that carbon intensive gas fired generation in the case of Ontario for generation during those peak times. So DERs are a good tool to lower the carbon intensity of our electricity grid. One last point from the individual customer's perspective is resiliency and reliability. Outages are unfortunately something that can't 100% be avoided, and that is increasingly so as we experience more extreme weather events related to climate change. DERs, especially when there's a battery involved, can provide some resiliency against those times when there may be a grid outage, even if it's just to power your essentials, to buy some time for your utility to work on restoration. It reduces the pressure on you as a customer when the power is out. You can kind of get by until the utility is able to restore things. So let's zoom out a little bit. You may be wondering why someone from a utility, me, is going on about the virtues of what you might consider to be a competing technology to our core line of business, which is supplying electricity to our customers. But DERs can actually be a huge help to our grid, and utilities are increasingly looking at how we can best enable DERs in a way that benefits all of our customers, not just those who have the solar panels on their own roofs, but everybody. In fact, at Hydro Ottawa, we highlight this in our current strategic direction. We have 8 key points in our strategic direction, and point number 4 is leverage and promote DERs. To understand why, it's helpful to remember that utilities have to build our grids to serve what you might consider the worst case scenario or peak demand. This is the time when the draw of electricity from the grid is at its highest. We need to make sure that on those hot, sunny afternoons when everyone's AC is blasting and people are getting home from work or school, starting to cook dinner, starting to watch TV, plugging in their electric vehicles, et cetera, the grid can handle all of that load. But for much of the time, demand on the grid is actually a lot less. We don't see those peaks all the time. So that means we have to build up to a capacity that isn't always being used. And with the changes that we'll see as a result of the ongoing energy transition, so electrification of heating, more electric vehicles, etc., as well as other driving factors like increased data center demands due to AI and the never ending march to digitize our society, we are going to see those peak demand periods that sort of max pull from the grid get higher and higher. Under the traditional approach to the grid, the only answer would be to build more and more. And with the pace that things are changing at, and have a listen to my last explainer episode on the energy transition for more on that. Relying only on the sort of traditional builds model would be expensive for all stakeholders, including our customers, and it would be hard for us to keep up with the pace of change. Don't get me wrong, our grid does need significant investment to expand to meet customer needs. We are going to be building out the grid, as we've talked about here, but that is not the only tool we have, thanks to DERs. So imagine if we could take that peak demand that I've been mentioning and lower it a bit, or shift some of that load from a peak time to an off peak time. Doing so would let us get more out of our existing grid assets and, in some cases, even delay or defer some big capital investment, a new transformer or a new substation, for example. DERs will help us do that. So, any individual solar panel or battery may not make the difference, but imagine tens or hundreds of DERs on a given feeder. That might be enough to shave that peak load by a significant amount. So something like a solar panel can be thought of as a passive benefit to the system, meaning it generates when it's sunny and up here in Canada when it's not covered in snow. So we get the benefit when the conditions are right, but they may not always be right. So we can't necessarily rely on them all the time. But if you pair that solar array with a battery, or looking a bit into the future with an EV, for example, which is basically just a battery with wheels, now we've got some control. And that control is where the real value lies. And it's with things like batteries and EVs, but also other smart connected devices, like your thermostat, for example. So there is a future not too far from now where you might get a signal from your utility saying, "Hey, we're getting close to our capacity on your feeder. So we'd like you to switch over to your battery, or we'd like to pause your EV charging for a few hours. Or maybe we want to bump the temperature up on your thermostat by a degree or two so you're not cooling so much just for the next few hours. And we'll give you an incentive on your bill if you let us do that." Now, you might say, "No, actually, I've got to get that EV charge because I'm about to head off on a weekend road trip or take the kids to soccer," or whatever it might be. Or, "No, I'm actually hosting a party tonight, so I don't want to mess with the AC right now. Thank you." So you can opt out of that call. But most of the time, you'd likely say yes, because sure, I mean, I'm home for the night. As long as my EV is charged by the morning, I don't care if it happens right now or in a few hours. And what's a degree or two for the next couple hours on my thermostat? I probably won't even notice. And I'll get that credit on my electricity bill. That action, that collective action multiplied over hundreds or thousands of customers can be the difference between having to build new infrastructure like a transformer or even a substation or not. And that has big implications on how much the grid costs and how flexible we are with the solutions that we're putting in place. Those examples that I just gave are kind of focused on the smaller DERs, but there's also a role for large DERs as well. These are things like 10 or 20 megawatt batteries that are playing that same peak load reduction role, but for a large scale industrial or commercial application, for example. Think about a massive customer. The same idea, reduce the magnitude of those peaks, but with a single massive device. So the ability to manage peaks is extremely beneficial to a utility trying to manage the grid, and DERs will be a really big part of that. So the question may be, why now? Why are we all of a sudden hearing so much more about DERs and seeing the start of what we expect to be a big ramp up of DER installations? As I said at the beginning, I mean, solar panels aren't a new technology. They've been around for quite a while. Batteries are evolving, but as you know, we've had batteries for a while. So there's a couple of reasons behind this. And before we jump into those, there's a caveat here that I'm obviously talking to you from Ottawa, Ontario. And so the context around what I'm going to say here is very Ontario, kind of North American specific. There are other jurisdictions in the world, Europe, for example, that are quite a bit further along than us when it comes to DERs, or at least their approach has been different in a different timelines. So keep in mind that I'm talking about sort of the local context here. So the first reason why we're seeing a lot more of this kind of boils down to basic economics and market forces. So, a rooftop solar array 20 years ago was something that could be considered a luxury item. It's extremely expensive, and in Ontario, at least prior to the feed in tariff program, which launched in 2009, there wasn't really even a great mechanism for recovering your costs. Kind of the best you could hope for was, eliminate your electricity consumption from the grid and thereby reduce your cost on your electricity bill, at least for the electricity portion. The last 15 or so years have seen significant changes in that area. So, programs like Ontario's feed in tariff and then sort of the subsequent evolution into our current net metering option have created a viable business case for putting solar up. At the same time, that solar technology and sort of the global value chains around that have evolved and costs have dropped exponentially. So, on a global scale, when we look at sort of cost of solar globally, the cost is now about 90% less than it was in 2010 to put solar up on your roof, for example. That is not a small feat. So think about how significant a drop that is. So that combined with government programs like tax credits, low or no interest financing options for DERs, and other energy efficiency measures. And all of a sudden, there's a really good business case for putting up solar. Solar, I would say, is the furthest ahead on that journey when you talk about DERs, but battery technology, EVs, et cetera, they're seeing a similar process where they are no longer just super high-end luxury items anymore. I mean, you've probably seen this as you look around. You probably see way more EVs out there. You see that green license plate that starts with GV. We're seeing these technologies become more common, the cost coming down, and more accessible for more people. Another main driver is just the need for these types of solutions as part of our energy transition. And again, have a listen to my last explainer episode on the energy transition for more on this. But because of the ongoing climate crisis, as well as increasing demand from things like AI data centers, the need for fast evolution in how we manage our grid, how we support our customers, how we provide the power that's being asked of us is really critical. And so that's why you'll see government programs that support DER technology, and hopefully we'll see even more of those moving forward. Lastly, what else needs to happen to get there? So I've kind of painted this picture of widespread DER adoption. It's everywhere. We're utilizing it. Utilities are making use of the DERs that are out there. That is not today's context, but I'm hopeful that it's sort of tomorrow's context, that we're on the cusp of that. What needs to happen to get there? Well, one of the big things is grid modernization. So I'll take this opportunity to give another plug to the episode that I did with Hydro Ottawa's Jenna Gillis earlier this year about our own grid modernization efforts. But essentially, we need to evolve our grid technology and the sort of system office technology. That's where we control the grid and our own IT infrastructure, how we communicate with our devices to the next level, which will allow us to do the kinds of things with DERs that I mentioned earlier. And as I talked about with Jenna, our efforts towards this are underway. This is a real project. This isn't sort of a concept that we're thinking of. This is something we're doing. That's underway. It's ongoing, and we're preparing ourselves for a DER future. That's one of the reasons why we're doing this. One of the reasons. Finally, there continues to be a role that governments at all level can play to further incentivize and enable DERs. So whether that's through incentives or subsidy programs, or updating existing regulations and rate classes so that the business case for DERs makes sense in sort of the areas or applications where they will benefit the grid and all customers. There's a role to be played there for government, and those conversations are underway. There are DER working groups in Ontario that we're a part of, and we're hopefully going to see more movement on that as we move forward. So hopefully that gives you a sense of what DERs are and why they're so important, why that acronym comes up on this show so frequently amongst our guests and the conversations that we have. They really are just one more tool in our energy toolbox that we will use to build that smart, clean, connected energy future that we talk about on this show so often. They are one of the ways that we're going to get there, and a big part of that. So thanks for listening. As always, send us your thoughts and feedback. Let us know topics that you want to hear about. We'd love to hear from you. And thanks for being a part of this conversation. Take care, everyone. Thanks for tuning in to another episode of the Think Energy Podcast. Don't forget to subscribe wherever you listen to podcasts, and it would be great if you could leave us a review. It really helps to spread the word. As always, we would love to hear from you, whether it's feedback, comments, or an idea for a show or a guest. You can always reach us at thinkenergy@hydroottawa.com.